Okay, so today we're going to look back at greatest common factor and least common multiple, GCF and LCM. And these three pairs of numbers are the examples we will be using today. And bear with me because I have to figure out my multiples as we go. But yeah, let's look at these. I want to point out something right quick. I'll kind of leave this on the side. I wasn't planning to leave this on the side, but this is something that kind of helps me remember. Okay, so I'm going to write this really, really small, all right? So when we are looking for the greatest common factor and the LCM of a number, I had told you that the greatest common factor would be smaller, right? Okay, that doesn't change. That's staying the same. And that this will be larger. Again, that doesn't change. It's still the same, okay? We already kind of went over this. What I would like you to remember is that, or something that helps me, and it's a good thing to remember, is that when we're looking for that LCM, the number will be quite a large number. So what I would like you to remember is that the GCF can be smaller or the same amount that these numbers are, the two numbers that you're given to find the GCF and the LCM. Whereas the LCM will be at least the number or larger, okay? And another thing I like to use, kind of like a little rule of thumb to remember, is this M in the LCM, this M here, kind of reminds me that I have to do more, okay? Whereas the greatest common factor, we can just remember as using the commons. But this LCM, I like to take that M and remember that kind of, or I make it stand and represent that we kind of are searching for more. That's what I use that M to remember. Okay, so let's remember that M equals more steps. We must do more, okay? That M right there. Alrighty, so let's look at the examples that I have here. And for starters, we have 42 and 64. We're going to use the factor trees, okay? So now what two numbers can we multiply to get to 42? Well, we can multiply 2 times 21, where 2 is prime, excuse me. And to get to 21, we can multiply what? Think about that for a second. We can multiply 7 times 3, okay, where 7 and 3 are prime. Now to get to 64, what can we do? Well, we can multiply 4 times 16. We have to break both of those down because two numbers can be multiplied to get to both 4 and 16. To get to 4, we can multiply 2 times 2. Let's circle out our 2's, those are prime. And 16, we can multiply, what, 4 times 4. Maybe you multiply 2 times 8, either is fine. We will still get to where we need to go. All right, and then 4 can be broken down again. We have 2 of them, so we have to do, well, we have 2 4s, so we have to break each one individually. To get to this 4, we can multiply 2 times 2. To get to this 4, we can do the same. So we have a bunch of 2's in this one, I see. Okay? Let's circle out all those 2's. So now, for 42, and we're looking for the greatest common factor first. That is what we will be looking for right now. Greatest common factor of 42 and 64. Let's line them up, smallest to largest. And I like to do this. If there is one number that we've ended up with more factors, aside from starting off with the factors that are smallest, I like to start off with the number that has many more factors, okay? So it doesn't matter at all. As long as you have your numbers lined up, I always do this, okay? I always kind of run out of room right here. I don't know why, okay? We have 2, 2, 2, 2, 2, and 2. Okay, and then for 42, we have 2, 3, and 7. So make sure one of those 2's are lining up. 2, 3, and 7. Alrighty, now let's go ahead and circle what we have in common. Well, all we have in common, there's no 2 to go in common with this one down here. There's nothing in common with this one, nothing in common here. Here we have these 2's in common. So that gives us a 2 in common. Now, 3 and 2 are not common, and 7 and 2 are not common. So the only thing we have in common would be 2. So our greatest common factor equals 2. We have nothing else to multiply that with because nothing else is in common. So we just have the greatest common factor of 2. Okay, now to find the LCM, we're using the same numbers, so nothing's changing. The factors are all still the same. Even the numbers lined up here are still the same. We can even keep this common one circled and remember that that is the same. But remember, least common multiple, M, more steps is how I like to remember it. We have to look for more. So yes, 2 is still in common, and that's fine how it is. That represents that we have a 2 in common. But now, let's see what else we have, even if it's not in common. Okay, so we have 2, 2, 2. This 2 here, a 3, a 2, a 2, and a 7. So now we have to multiply all of those. And I know this kind of looks like a negative 2, but it's not. Okay, I just underlined it to show you what we have. So now let's multiply all of those. Okay, we have 2 times 2 times 2 times this 2 that we had in common right here, but that's just, we're going to use that 2, just 1, 2, not 2 of them. Okay, and then we have 3, 2, 2, and 7. Oh my gracious, I keep doing this. Okay, let's start this. We have 2, 2, 2, and 2. And then over here we have 3, 2. We have 7 and 2. Now you just multiply all of these. So when we multiply all of these, let me switch colors right quick. We have 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3, let's see, 16 times 3. 6 times 3 is 18. Put your 8, carry your 1. 3 times 1 is 3, plus 1 is 4. So that means this is 48. Now let's see, 48 times 2. Okay, 8 times 2 is 16. Put your 6, carry your 1. 2 times 4 is 8, plus 1, that's 9. So we have 96. Okay. Now let's see, 96 times 7. Alrighty. 7 times 6 is 42. 9 times 7 is 63. Plus 4 is 67. Okay, so then I'm running out of space here. But we have 672. Now let's multiply 672 times this last number. 672 times 2. Okay, so 2 times 2 is 4. 2 times 7 is 14. Carry your 1. 2 times 6 is 12. Plus 1 is 13. So our least common multiple is 1,344. Okay? 1,344. Alrighty, so that's quite a difference of the greatest common factor. That was 2, whereas the least common multiple is 1,344. So let's look at another one. Maybe you'll get a little bit more of a gist. Okay. We're going to look at 30 and 95 now. Okay. Now, what two numbers do we multiply to get to 30? Well, you can do 3 and 10. 3 is prime. 10 we break down to 5 times 2. 5 and 2 are prime. Now, 95 we can multiply 5 and 19 to get there. Okay, 5 is prime, 19 is also prime. You cannot multiply two numbers to get to 19. Okay, let me give you an example. 8 times 2 would be 16. 9 times 2 would be 18. We can't think of two numbers that can multiply and give us 19. So 19 is prime. That's all that prime means. Okay. The only thing that you can multiply to get to 19 would be 19 times 1. The only thing you can multiply to get to 5, you can't do 2 times 2, that's 4. You can't do 2 times 3, that's 6. So that tells us that the only thing we can multiply to get to 5 would be 1. So we can multiply 5 times 1 to get to 5, but nothing else, okay? But that's covered in the prime numbers video, or prime factorization and whatnot. Prime numbers, I think I called it. Okay, so anyway, we are here at the bottom. We have our prime numbers. There's nothing else we can do. So let's line them up and see where we are at, okay? So for 30, 95. For 30, we had 2, 3, and 5 in order. So 2, 3, and 5. And for 95 here, we had 5 and 19. Let's line up that 5 and push this 19 out here because we know we don't have anything in common with it. Okay, so we're looking for the greatest common factor again, right? Okay, greatest common factor is we just look at what is common, okay? 5 is all we have in common. We can't multiply it times 3, that's not in common, or I'm sorry, we cannot multiply what we have in common times what is not in common. So 2 is not in common with us, 3 is not, 19 is not. We only have 5 in common, okay? So that is the greatest common factor of 30 and 95. Now let's try to find the LCM. All of this can stay the same, but let me take out these slashes from 19, from 3, and from 2. Okay? 5 we still have in common, so we'll just remember that we have a 5 in common, and we will exit these 2 out. We just need to have it one time because we have it in common. Okay? So now what we would do for the LCM is what? We have to do more steps. We have to use more things. So remember that we're not just looking for what's in common, we're looking for all of the factors. So we have a 2, a 3, a 5, and a 19. Okay? So let's multiply those. For the LCM, we have 2 times 3 times 5 times 9. Now let's figure that out. 2 times 3 is 6. 6 times 5 next is 30. And now 30 times this last number here, 9. Let's figure that out. 30 times 9. 9 times 0 is 0. 9 times 3 is 27. Okay. I did 9. I was supposed to do 19. Okay, so let us multiply 30 times 19. My apologies. Okay, that was not a 9. That was a 19, correct? Yes. Okay, so 30 times 19. Okay. 9 times 0 is 0. 9 times 3 is 27. We're done with this 9. Hold our place value of 0. 1 times 0 is 0. 1 times 3 is 3. Let's add those together. 0 plus 0 is 0. 7 plus 0 is 7. 3 plus 2 is 5. So our least common multiple equals 570, okay? As opposed to the greatest common factor, that was only 5. Again, your greatest common factor is going to be smaller or equal to or smaller than the numbers we're looking for, whereas your least common multiple will be at least the numbers we have or larger, okay? So hopefully you're getting a good idea. Now let's work on this last example here, okay? All right, we have 50 and 130, okay? So let's use those good old factor trees. How can we get to 50? Well, we can multiply 5 times 10. 5 is prime. 10 we have to break down a little bit more. Okay, we can do 5 times 2. We are there now at the end. For 130, you can multiply, think about what you're going to use, but I'm going to use 13 times 10, okay? And 13 is prime, so we're good with the 13. Now let's break down that 10 a little bit more. Okay, we could break it down to 5 times 2. All right, and first we will look for the greatest common factor, correct? That's what we've been doing. All right, you know what? First, let's look for the LCM, okay? Just to kind of throw you a little dozy. Maybe that's how they say it. I'm not sure. Okay, that's why I do math. Okay, so I'm probably going to need a little bit more space to show you this. Okay, so the LCM this time we are looking for first. The last 2 examples we looked for the greatest common factor first. This example, I want us to find the LCM first. Okay, I'm still going to need more room than that. Okay, let me go down here to the bottom. LCM we are looking for. Okay, we had 50 and 130. For 50, what factors do we have? We have 2, 5, and 5. 2, 5, and 5. And for 130, we have 2, 5, and 13 in order. So we have 2, 5, and 13. Alrighty, so we can still look at what's in common and remember to use that just once. Okay, so instead of 2 2s, we have 1 2 in common, correct? So we use a 2. Instead of 2 5s, they're in common, so we're just going to use that 5 one time. And then for the LCM, remember, we don't just use what is in common, we use all of our factors. So when we look at this now, we have 2 times 5 times what still wasn't in common, 5 times 13, okay? So 2 times 5 times 5 times 13, alrighty? Now, 2 times 5 is 10, 10 times 5 is 50, and then 50 times 13, well, let's figure that out. 50 times 13, 3 times 0 is 0, 5 times 3 is 15. We're done with that 0, hold our place value of 0. 1 times 0 is 0, 5 times 1 is 5. Now let's add these together. 0 plus 0 is 0, 5 plus 0 is 5, 5 plus 1 is 6. So our least common multiple is 650, okay? Hopefully I wrote that well enough for you to see it, but it's 650. Alrighty, now let us find the greatest common factor, okay? That was the LCM. LCM was 650. Okay, now we're looking for the greatest common factor. Doing it backwards. Alrighty, not backwards, just out of order from what we've been doing it, okay? So everything's still the same. For 50, I didn't even have to erase that. For 50 and for 130, for 50 we had 2, 5, and 5, 2, 5, and 5, and then for 130 we have 2, 5, and 13. Now I know you are probably thinking, hey, this greatest common factor is kind of easy, I've got it down packed. But for the last 2 examples, we only had 1 thing in common. Well, this time we have 2 things in common, right? This 2 and 2 are in common, and this 5 and 5 are in common. This 5 and 13 are not. We're not going to use those for the greatest common factor. We're just going to use what's in common. And again, when you circle something, that means you use it 1 time. Okay, we circled the 2. And we circled the 5, those are in common. So let's just multiply what we have in common. We had a 2 and a 5 in common. So 2 times 5 equals 10. Our greatest common factor was 10. Okay, so that is, again, a large difference where the greatest common factor is smaller and the least common multiple is larger. We had to look for more things. It was more steps. Okay, so just keep that in mind. It's a good thing to look back at and make sure that you have both of those down and you understand the difference. Again, least common multiple, we're looking for more, okay? That's a good way to remember the difference.